All right, today we're going to continue on with the Algebra 2 review, and we're going to do radical equations. Now, you would have done these last year, so hopefully this is just going to be just a quick reminder of what you need to do whenever you're working problems. So if you were to have something like the square root of 2x minus 5 is equal to 16, then you are going to square both sides. And then you would get 2x minus 5 is equal to 16 squared, which is 256. Add 5, so 2x is equal to 261. Divide by 2, and you get 261 over 2. And go back and check. And basically the check for you guys should kind of be, does it work? So, I mean, does it like make a negative number when you're doing that? I can put it back in, and I can say 2 times 261 over 2 minus 5 equals 16, and that would be a true statement. If you're kind of thinking of another check you can make with this is like shifting it to the right 2.5, and it goes like this. 16 would be here, so I know I do have one intersection point whenever you're doing that. Okay, the problems could get a tad more complicated. So if I had something that was like the square root of 3x minus 5 is equal to x minus 3. All right, I've got a square root isolated over here. So all I have to do on this particular point is to square both sides. So 3x minus 5 is equal to x squared minus 6x plus 9. So square. And then you're going to set it equal to 0 to solve for x. So that gives me 0 equals x squared minus 9x plus 14. So your next step would be to factor or to use quadratic formula. So this one does factor, x minus 7 times x minus 2. So setting each part equal to 0. You get x is equal to 7 or x is equal to 2. So again, go back and check your answer for this. When I've substituted in 7, I get the square root of 21 minus 5 is equal to 7 minus 3. So the square root of 16 is equal to 4, which is true. The square root of 3 times 2, which is 6, minus 5 is equal to 2 minus 3. So the square root of 1 does not equal negative 1. So 2 is an extraneous solution for this. So the only thing that you would have for an answer would be 7. Okay, it is possible for there to be more than one square root in a problem. So you really need to be careful when you're working the problems like that. So the square root of 2x minus 5 is equal to 1 plus the square root of x minus 3. Again, I have one of them isolated. It's not possible to isolate them both. So you're going to have to square this, but you need to think about the process of the squaring of this one. So the square root of 2x minus 5 squared equals 1 plus the square root of x minus 3 times 1 plus the square root of x minus 3. So this one is easy. This one, however, gives me 1 plus 2 times the square root of x minus 3 plus x minus 3, because you've got the inside outside terms with that. So collecting your like terms, you would have negative 2 plus x plus 2 times the square root of x minus 3. Move things over so you're isolating your variable here. So that's going to give me x minus 3 is equal to 2 times the square root of x minus 3. Now we're back to getting rid of that. So again, we're going to square both sides. So x squared minus 6x plus 9 is equal to 4 times x minus 3. Don't forget that you need to put that together with the 4. So x squared minus 6x plus 9 equals 4x minus 12. So moving things over, x squared minus 10x plus 21 equals 0. So that would factor to x minus 7, x minus 3. So x is equal to 7 and x is equal to 3. So again, you need to go back in and check your answer. So putting in 7 gives me the square root of 14 minus 5 equals 1 plus the square root of 7 minus 3. So the square root of 9 equals 1 plus the square root of 4, and that's true. So putting in 3, the square root of 6 minus 5 is equal to 1 plus the square root of 3 minus 3. 1 is equal to 1. That looks like that's true, so you should have 2 answers. Doesn't feel like that's right, but okay. Now, this is just a be careful. And you need to remember that a square root cannot equal a negative number, because you want to continue to do the math whenever you're working the problems. So if I were to have something like the square root of x minus 7 plus 8 is equal to 3. So working the math, you get the square root of x minus 7 is equal to negative 5. And you guys get in the mode of just doing something, so square, and you get x minus 7 is equal to 25, x is equal to 32. So all seems great and good. If we put it back in, the square root of 32 minus 7 plus 8 equals 3. So the square root of 25 plus 8 equals 3. No. So 32 would be extraneous. There is no solution to this problem. Now, really, when you got to the point right here, so if I had the square root of x minus 7 equals negative 5, this is not true. So at that point, this is invalid, and you can see that there's a problem when you're working it. So that's basically all you have for radicals. I guess I should do, if I were to have something like the cube root of x minus 5 is equal to negative 2. Okay, this is a cube. It can equal a negative number. So getting rid of a cube root means I'm going to cube both sides. So that would give me x minus 5 is equal to negative 8. X is equal to negative 3. Plugging it back in, the cube root of negative 3 minus 5 equals negative 2. So the cube root of negative 8 does equal negative 2. So that's okay. So just remembering that if you have a cube or an odd root, it can equal a negative number. So that's basically all that we have for this. So hopefully you guys are going to remember what you need to be doing with that, and you can have a good day. Thank you. Bye.